Hi, Adam Glick, BOXX Labs here. Today we're going to talk about render speed, and we're going to do a little render farm shootout, if you will. What we have here are two of our renderBOXX modules. On the right is the new 10300. On the left is the older but still quite useful 10200. The way we ship our renderBOXX modules is that each module contains two render nodes, two individual identical computers, one here and one here. It's just a very high efficiency, high density way to package these so that people can put lots and lots of rendering power in a relatively small space. So for our tests today, we're only going to use one render node from each of these render modules and compare the relative rendering performance between the new Nehalem-based render nodes and the previous Xeon 5400. Okay, onto the hardware. On the left, we have the renderBOXX 10200. This is the previous model. We're running Vista 64, 8 gigs of RAM, and we're running the Xeon 5482 Xeon processors. Again, we're just using one of the render nodes of the two in this module for testing purposes. These CPUs are running at 3.2 gigahertz. So we have 8 cores, 3.2 gigahertz, Xeon 5400. On the right, we have the new renderBOXX 10300. This is Nehalem architecture, right? This is, again, just using one render node, one of the two in the module. Again, Vista 64, we're using 6 gigs of RAM in this system. We like to stay with multiples of 3 gigs for memory performance reasons. But these CPUs are the 5580, the W5580, running at 3.2 gigahertz. Again, 8 cores, but with hyper-threading, the software in OS sees this as a 16-core system. And you'll see that the performance can be helped by that. So let's launch Cinebench 10 on the 10200. And let's launch Cinebench 10 on the 10300. Okay, so I'm going to start the rendering, the test on these two machines at the same exact time. Let's see which one finishes first. Ready? 1, 2, 3, go. Okay, so down here at the bottom you might see these graphs. This is the Windows Task Manager. We're seeing 8 windows here that show the CPU core activity. And you can see that all 8 cores now are just pegged right at 100%. Over here on the 10300, these Nehalem architecture systems, they're quad-core chips. So 2 of that is 8 cores, but with the hyper-threading, system actually shows up with 16 processing cores for software. The new multi-threaded software applications can really take advantage of that. And you'll see here that Cinebench is just pegging all 16 cores. Looks like the 10300 has finished up with a score of 30,011 CPU points. Not bad. Over here, the 10200 system just finished up, just this very second, with a still, respectable but not nearly as good score, 23,102. And the prize goes to, ding, 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 the renderBOXX 10300 with the Nehalem microarchitecture is a roughly 30% faster per clock speed than the previous generation. So what do the tests show? The tests show that while both systems run at the same clock speed, 3.2 gigahertz, the new Nehalem microarchitecture that we're using in the renderBOXX 10300s render about 30% faster than the previous generation Intel Xeon 5400 series chips. Roughly the same price, about 30% better performance. You do the math.